Okay, so let's go back in time a little bit. I'm not too sure to what year level, and let's look at short division and long division. So 5 goes into 247. Yeah. So if you remember from your short division, 5 goes into 2, doesn't. 5 goes into 24, so it's 4 times. 4 5s are 20, and we have a 4 remainder. And then we go 5 goes into 47. What's that? 9 5s are 45, so it goes 9 times. And we have 2 remainder. And then if we want to keep going, we put a decimal point and we put a 0. 5 goes into 24 times. And so we get an answer of 49.4. Yeah? Now, so that was the short approach. Let's have a look at the same sort of thing, but in long division. So 5, it's a bad 5. Let's tidy that up. Into, what is it? 247. So it's the same principles. 5 goes into 2, it doesn't go. 5 into 24. So how many 5s are there in 24? Well, there's 4 of them. So to work out the remainder, we do 4 times 5, which is 20. Subtract them off. 2 minus 2 is 0. 4 minus 0 is 4. We get our 4 remainder. Then we bring the next term down, don't we? Which in this case was the 7. And now we do 5 into 47. What's 5 into 47? Well, 9 5s are 45. So we can go 9 times. Then we do 9 times 5 is 45. Subtract off, we have 2 remainder. So it's 49 remainder 2. So we're not going to worry about going into decimals here. But again, we could put down the 0, put down a 0 and we get our 4. Instead, I'm going to write it goes 49 remainder 2, which is 49 and 2 over 5. Okay? Now, what I'm going to try and show you now is using this long division approach to do the same thing with polynomials. All right? So, now we're only going to do it very basic with these ones. X minus 1 goes into x plus 3. Okay, so instead of asking myself, over here I sort of asked myself how many 5s were there in 24. I'm going to instead say, what do I multiply 5 by to get as close to 24 as I can? Okay, so 4 times 5 is as close to 24 as I can, so I do 4 times 5, okay? So here I'm going to say, what do I multiply x by to get x? And in this case, it's just, it's just 1, isn't it? Because 1 times x is x, 1 times negative 1 is negative 1. And let's subtract. X minus x is 0. 3 minus minus 1 is 3 plus 1, which is 4. So for us, we can stop now at this. What do I multiply x by to get 4? There isn't anything. You know, there's got to be 1 on x and things like that. There's no integer or whole or positive indice. So there's my remainder. So really the answer to this is 1 remainder 4, yeah, which we can write as 1 plus 4. What has 4 yet to be divided by? 4 is yet to be divided by x minus 1. So that same expression here can be written as 1 plus 4 over x minus 1, which is in fact a hyperbola, and you can see my asymptote at positive 1, and we can see it's been shifted up 1 unit. All right, let's do the same thing for the second one. If I've got x minus 2 goes into 2x plus 1. All right, question again, what do I multiply x by to get 2x? And the answer is 2. So I've got to multiply everything here. 2 times x is 2x. 2 times negative 2 is negative 4. Let's subtract off. 2x minus 2x is 0. And if you've done it right, you'll always eliminate that leading term. 1 minus minus 4 is 1 plus 4, which is 5. So again, in this case, my answer is 2, remainder 5, which can be written as 2 plus 5, which is yet to be divided by x minus 2. All right, so if we just take that one more question and do exactly the same thing here for this example. Let's sketch this graph now. Y equals 1 minus 2x over x plus 2. Who knows what that looks like? So instead we do our division, and we know we have to do a division going forward because the degree of the two terms on top are the same. Okay, if it's the same or if the top is bigger, we need to do a division. So that's x to the 1 over x to the 1, so there's a division there that has to happen. So I'm going to write x plus 2 goes into 1, we'll just change the order, minus 2x plus 1. That way we've got the x terms at the front again. Again, what do I multiply x by to get negative 2x? It's minus 2. Negative 2 times x is negative 2x. Negative 2 times 2 is negative 4. Subtract them. Negative 2 minus a minus is a plus 2, so it's 0. 1 minus minus 4 is a 1 plus 4, which is 5. So again, negative 2 remainder 5, or y is equal to negative 2 plus 5 over x plus 2. So again, from the information or from our knowledge of earlier, we can see that, well, let's rewrite it into the form that we're familiar with. Y is equal to 5 over x plus 2 minus 2. So first things with our hyperbolas, we sketch our asymptotes. So we know that this graph has been shifted to the left 2 units, and it's been shifted, wrong way, must go up, down 2 units. Yeah, so I'm going to get my ruler out. It's been shifted down 2 units, so I'm going to treat that as a 2. So asymptote there. And we're going to label that as y equals negative 2. Vertical asymptote, 2 units to the left, even though it's a positive 2. And I can say x is equal to negative 2. Now I know the other key piece of information here, and maybe if you don't recognise it, is actually there's no other key piece really, is we've got a positive x there. So it means that our graph is top left, bottom right. Let's get intercept, at least one intercept. So if I put x equal to 0, so the y-intercept, I put x equal to 0. Now I could do it there, and I'll get 1 minus 0 over 0 plus 2. So I'll get y is equal to a half. Or if I put it over here, I'll get y is equal to 5 over 2 minus 2, which is also a half. So I get the point 0, a half, which using this scale, hang on, that's 2, that's 1, there's a half there. So we can see the x-intercept should be over here somewhere. Okay, so let's check an x-intercept. If I put y equal to 0, we didn't have to get the intercept, but that's okay, it's still good practice. If I put y equal to 0, I get, what do I get? I get 5 over x plus 2 minus 2 is equal to 0. 5 over x plus 2 is equal to 2. Multiply the denominator across and then bring the 2 back. So then I get 5 on 2 is equal to x plus 2. Subtract 2 from both sides. I get 5 on 2 minus 4 on 2 is equal to x. X is equal to a half as well. So it's actually quite a tight fit, isn't it? If that's 2, that's 1, that's a half. So my graph looks a little bit like that. Note the equations or the asymptotes approach, the lines approach the asymptotes but don't cross them. Okay, and importantly, especially given our current emphasis on domain and range, what is the domain and range of everything? So the domain is all the x values, remember, and I can have all the x values except for -2. And my range, I can obviously have all those y values, so let's just pick a nice different colour there. So my range, I can have all of those values to there and then pick it up again. So that's the problem there. So my range, again, is all the real numbers except for -2 also. Okay, so this will help in particular with questions 4, 5 and 6. Of the questions.